Alright, here we go. Video number 2 on polynomial functions. Okay, so a polynomial function, you guys know what polynomials are. They're basically equations with a whole bunch of exponents and leading coefficients and stuff. So if you don't have any variables, that's called a constant, so its degree is 0. If you have a degree of 1, it's a linear equation, which means it's just, say, 5x. It's got x with no other exponent. If it has an exponent of x squared, that's a quadratic, degree of 2. The degree is the highest exponent. Okay, and then of course they can just go right ahead and decrease as they go. The highest one is what you want. A cubic is an x cubed of degree 3. Degree 4 is a quartic. And degree 5 is a quintic. And then you don't have to know anything after that. So a couple of rules about polynomial functions. You will have whole number exponents. All coefficients are real numbers. And again, no negative exponents. We do not like negative exponents. So number 1, we're going to decide whether or not the function is a polynomial. If it is, we are going to, write it in standard form and state its degree, type, and leading coefficient. And if not, we're going to explain it. So the first one is no. It's not. And there's my explanation right there. I just circled it. No negatives. And B. Is B a polynomial? The answer is yeah. So we have f of x is equal to x to the 4th minus 0.8x cubed minus 5. Okay, and then our leading coefficient is 1. The degree is 4, so it's a 4th degree. And that means it's a quartic. So that's how we handle these kind of problems. If it asks you to describe some the degree, the name of it, leading coefficient. When it says standard form, that means descending order. You start with the highest and work your way down. Okay? Now, evaluating a polynomial, it says that you can do it with a graphing calculator, which is totally cool by me, but if you want to do these by hand, you can totally do these by hand. So I apologize about the notes. That is actually supposed to be on the next page, but since this is a PDF document, I can't change it. So you could use your calculator. You can type the polynomial into Y1. You can press second table and look at it. You can go to ask and do it that way. You can trace it, but I like not tracing because tracing isn't always accurate. Or you could do it the good old-fashioned way and just evaluate it. So what's f of negative 2? And that would be 3 times negative 2 to the 5th power minus negative 2 to the 4th power minus 5 times a negative 2 plus 10. And you can just type it into the calculator manually, and you're going to find out that f of negative 2 is going to be equal to a negative 92. So you could do it that way as well, or you can use your graphing calculator to do the work for you. Okay? So again, I apologize about the split notes here. I cannot retype these at the moment. So you're just going to have to pay attention really quick. We're about to talk about end behavior. Now, end behavior is what a graph does as it goes to the left and as it goes to the right. So end behavior happens when a function x goes to plus and minus infinity, or to the right and to the left. So what we're going to do is we're going to graph and describe the end behavior. So we're going to use our graphing calculators to graph these, okay? I don't expect you to know how to do these by hand, except for after you do a couple of these, you're going to understand the basic shape of them. So if you were to type A into your graphing calculator, you're going to get a graph that looks a little bit like this. He's going to come down, he's going to come back up, he's going to go down, he's going to go back up, and that's going to be a W. So right now we're just talking about the end behavior. So the way we talk about it is as x approaches negative infinity, meaning as x goes to the left, what does the function do? F of x is approaching positive infinity. So what is it doing for y? So as x goes to the left, your graph is going up to positive infinity. Okay, and then you have to do it again as x approaches infinity. Okay, so as x goes to positive infinity or to the right, what is your graph doing with the y? It is also going up, so it's going to positive infinity. That is end behavior. You just need to look at what the ends of your graph are doing. Okay, so you try B really quick. So you have a graph that looks a little bit like this. And what you're going to do here is you're going to look, and again, as x is going to the left or negative infinity, and x is going to a positive infinity, what is the graph or y doing? So as x is going to negative infinity to the left, the graph's actually going down. So the graph is also going to negative infinity. As x is going to positive infinity, what is the graph doing? He's also going up to positive infinity. So if you got that for B, you are good. So now we're going to fill out a little chart. And this little chart will help you do this end behavior stuff without actually having to look at the graph. So n is your exponent. So if your exponent is even, as you go to negative infinity, then you are going to have a graph that goes to positive infinity. And as x goes to infinity, the graph is also going to go to infinity. Now go back and look at example A up here. It's an even exponent and it's positive. Whenever it's even, they're going to be going in the same direction. So it's going to be going up to the left and up to the right. Okay, but if there was a leading coefficient of a negative, or if your first coefficient is negative but your exponent is even, then they would both be going down. So this, here's a little example for you. If it's even but it's negative, then they're going to be going down. So both of these will be going to negative infinity. Okay? Now, if it's odd, if it's a positive odd polynomial, you start low and finish high. So as you go to the left, negative infinity, the graph goes to negative infinity. As you go to the right, positive infinity, your graph goes to positive infinity. But if it's a negative odd, it's opposite. It starts high and finishes low. So that would switch to positive infinity, negative infinity. Okay, so once you get good at this, you'll just be able to look at it and you'll be able to describe the end behavior without having to use your calculator. But if not, hey, guess what? You have a graphing calculator, so use it. So, speaking of graphing calculators, you're going to need it, and these are all just some refreshers of skills that you should already have, because in this chapter, if I ask you to graph a polynomial and describe its end behavior, when I say graph a polynomial, you might have to list a lot of important information. So what do I mean by important information? Well, important information is going to be x-intercepts, y-intercepts, local maximums, and local minimums. And you'll have to describe the end behavior. So in number 4, if you just paid attention, as the graph goes to the left and as the graph goes to the right, we can already predict what y, or the actual graph, is going to do because of, we know it's positive and odd. If you remember, positive odd starts low and finishes high. So to the left, it's going to be low. To the right, it's going to be high. But of course, if you need your graphing calculator to do that, you can use it. So you type this into y1, and this is what the graph looks like. It's going to look a little something like this. And when you do these, you don't just get to sketch it like that and leave it alone. You must label all important information, meaning any x-intercepts, any y-intercepts, and any what is known as local maximum and a local minimum. Now, the reason I call that local max and local min is because, look, the graph's going down forever and ever and ever. So he's never going to have a minimum. It's also going up forever and ever and ever. So he's never going to have a maximum. Now, a parabola, the bottom, the vertex, that is an absolute minimum because there's nothing else that goes down. But see how where this trades here? So it's going up and now it's going down. That's called a local maximum. But you already know how to do all of this with your calculator. To find the x-intercept, remember y2 is 0, go find the intersection. To find the y-intercept, just press second table and look at where x is 0. To find the maximum, you just use second calc. Number 4, I believe, is maximum. You do left bound, right bound guess. Same with local minimum using your second calc. And you find all of these points. So get your calculator, do it, and see if you get the same answers as I do. Press play when you're ready. So the x-intercept you should have found is negative 2.757, comma 0. Your local maximum is negative 1.549, comma 5.631. Your y-intercept should have been 0.3. And your local minimum is 0.215, comma 2.887. And that's it. So again, the skills you already have. You already know how to use your calculator to do so. Just make sure if it's asking you to graph and state all the important information, that means intercepts, maximums, minimums, and end behavior. All right, this is Longo, and I am out. See you, bye.